Assalamualaikum and very good day. Welcome back to Computer Programming, BITG 1233. So we are going to continue on the next topic, which is structured something. Let me go check it. Structured data, and I will share my screen now. All right. Let's get on to it. So this lecture was prepared by Madam Marliza Ramdi from the IT department or IT faculty. So for this topic, we want you to be able to describe the concept of structure in C++ programming. And then we will be able to differentiate between array and structure, because previously we have learned about array and how it is different from structure that we are going to cover this time. All right. Structure is basically a collection of related elements pertaining to a certain topic or a certain variable, possibly different types, and having a single name, okay, such as name or ID or maybe color or something characteristic about that particular stuff. C++ construct allows multiple variables, and each variable is an element of a structure. All right, so let's take a look at this thing. So basically, first example is a fraction that has two fields, both integers. Okay, the second example about student has three fields: an integer number, a character array, and a floating point. So these two things in this first example, these two things, the number 5 and also the second one, number 7, are two things about the same thing, the same thing, which is a fraction. So a fraction, we have the top part, numerator, and the bottom part, which is the denominator. So those things belong to the same fraction, okay? So that's how they are related. In this second example, we want to have some information about a certain student. So say this student has a name Fatima, and that's the name of the student. And then ID related to that student is 1234, also related to the same student. And another thing that is related to her is her grade points, which is 3.7. That's a first class honor. All right. So this is the way how we declare a structure. Okay, structure. Then in the pointy bracket, we have the structure name. And then under it, we have types of the information, and then the field name. Field name, the first one, and then the field name, the second one, together with its type. Okay, and then we have this bracket, squiggly bracket or the curly brackets. And after the second one, the closing bracket, we have the semicolon. Structure, okay, so usually we have to put this this declaration on the top part of our program, our code. Structure declaration notes must have the semicolon after the closing curly bracket. And then multiple fields of the same type can be in comma separated list. Okay, so this is as usual. If say this one is of character or char type, so name is a character, address is a character. They have different sizes, so they can have in the same. You can declare them in the same line. So define the variable of a structure type. Use the structure name as the variable's type. Okay. All right. So that's about it. So this is one example of a structure called student. So related to student, we have the student ID, the student name, the year in school, and also the GPA of the student. Okay. So meaning this declaration of this structure will be on the top part of the code, and it is called student. Then its variable will be student build or structure student build, right? So the word student is already known as a structure. So under the build, under student build, so this is basically creating a different type, So the variable name will be build, and then there'll be a dot, and then student ID, build dot student name, build dot year in school, build dot GPA. Okay, that's the situation. Structure can be initialized. The rules of structure initialization are similar to the rules of array initialization, where the initializers are enclosed in braces and separated by commas. Okay, so braces, I guess, will be the kind of like the regular bracket, regular bracket, or maybe even braces will be the squiggly bracket. Sorry, the curly bracket braces. The initializers must match their corresponding types. Okay, and if a nested structure is used, the nested initializers must be enclosed in their own set of braces. Okay, we'll see. This is one example of a structure type called sample. And in this sample structure, we have X, Y, T, and U. Okay, X, Y, T, and U. So we can have different numbers. So in this case, X, Y are integers. We can actually declare them in the same line. Then we have a floating point or floating number T, and then a character A. So for example, we have sample SAM1, and it is 2, 5, 3.2, and A. So you must follow this this arrangement or sequence X, Y, T, and U. So if we have we declare only just 2 for this SAM2, so meaning the first 7 will go to the first 2 variables of 2 information. The others will be 0. All right. We can read data into the right data from the structure members, just as we can from individual variables. So just like as I mentioned earlier, you use the dot operator to separate between information from the structure. For example, okay, cin SAM2.x. So meaning we want to read that information into sem2.x, then sem2.y, sem2.t, and so after the dot will follow this information. So we have x, y, t, and u. So same over here. The structure is an entity that can be treated as a whole. However, only one operation or assignment is allowed on the whole structure itself. In other words, a structure can only be copied to another structure of the same type using the assignment operator. So for example, SEM2, and this is SEM1. If I say SEM2 equals to SEM1, meaning SEM2 will copy all the information from SEM1 into this new information. So displaying a structure variable. To display content of structure variable, must display each field separately using the dot operator, so such as this one. So this one you want to print out. So using the cout command. So cout less than bill.student ID, and so it will print this information, bill.student ID, bill.student ID. And so on. So if we have the empty thing between the quotation marks, so we'll have some gap, I would say gap between year in school and then the GPA. So we cannot compare structure variables directly. For example, if Bill equals William, this one won't work. So because you have to specify which information on the bill that you want to compare. Instead, must compare on a field basis. So for example, bill.studentID equals to william.studentID. Okay. All right, so in this next one, we have a structure called student start data. And then in start data, we have ID, name, and also grade point. So they have integer type, character, char, and also float. And in the main function, we declare student BITG 1113 as one variable. Then cout, we print out this statement. Please enter your ID. Then after the user enter the ID, the system will read that information as student ID, studbitg.id. So, and then the next one, please enter your name, and then cin get line. Okay, so this is another way to do that. So we give a space of 19, even though in the initializer, we have our declaration, we have 20 spaces. And then cout, please enter your grade point, which is the last one, last information that we require. And then we read that as that. Then what we'll do next is to print out the information that we already got, or we just received from the user. So where we print out the information from the memory, So here we read student ID and then student BITG name, and then the last one will be the grade point average. So from that information, we can also have a if statement where if the grade point is larger than 3.5, so we can have a statement saying it is excellent. So of course, we need a what call that? I guess we forgot the semicolon there. Add that. Save that. I guess I should save it as also as a PDF before I forgot. Okay, back to this part. Nested structure. We can have structures as members of a structure. So when we have a structure, nested loop, when a structure includes a structure, it is a nested structure. For example, we can have structure called STAMP, STAMP, that stores the data and also the time, the date and time. The date is in turn a structure that stores the month, data, and day and year. The time is also structure, one that stores the hour, minute, and second. So we have structure within a structure. So for example, here we declare the date, the time, and also the stamp. Okay. So I guess the sequence is not that important. You can declare stamp first, or maybe it is important. All right, so we can just follow this thing, and then the next one we just declare something called stamp, and it is of the stamp structure or stamp type. It is possible to nest the same structure type more than once in a declaration. For example, we have a structure called job, and then in this job we have the start time, also the end time. Okay. And then we have job. So this is variable, and this is the data type. So this data type is we create this data type instead of the regular data type, which is like integer, float, char, and also bool. Okay, so referencing nested structure, when accessing a nested structure, we must include each level from the highest stamp to the component being referenced. For example, we have stamp, and within stamp, this is the lowercase stamp. And then we know that within stamp we have date, and in date we have month. So here in the second one, we have stamp, time, and after time, we still have some more information that we can go into, which is second. So each time we separate them with the dot or period. Structure can have one or more arrays. So global declaration here, pupil as the data type that we create under structure. And here we have name, midterm, and also final. So if we create a variable student, and that is of the pupil type. So here a structure with array as member. Array as member. So we have understood data. We have name, test, assignment, I would say, and also quiz. And then after that, we have final, total, and also project. So in the main, it is a void. So here we declare student BITG 1113 using this type, data type, start data, which we created. And then we have floating type, total test, third S, and third quiz. So we initialize them with the value of 0. And then cout, please enter your name. So this require some user input. So, and of course, name is of a character type. So we use cin getLine, okay, and student, we call this student by ITG, and that is the name. And say the space is 19. So in the next one is a for loop. So we initialize I for the counter or index, and that starts from 0 until so because it is integer less than 3 is 2, from 0 to 2, and I variable I or the index I will be increasing. So cout, please enter the score for tests. Okay. So test number what? Test 1 in this case. Test 1. So because we start from 0, so you cannot say test 0. Yes, and then cin BITG and whatnot. So this will give you the next information, which is the test score. And then total test, we're going to increase total test and plus that with the, so initially the value of total test is 0. So now it's going to keep on adding the information of the test score that we have just included. And then another loop also from 0 to 4. Okay, less than 5 is 4. So here, so meaning you're going to get 5 values here. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay. So cout, please enter the score for assignment. Okay. And then we give the value there, I plus 1. And then the the colon. And then cin BITG assignment. And then total assignment will score will keep on adding, keep on increasing. And then the last information or next information is for quiz. So this one will also be required for using user input. So and then we are going to keep on adding the quiz marks. And the next one, see out, please enter the score for final exam. So this one will also require from user input. And then the next one will project score. And then the last one is the total. So total will just add all the information from what we already got from the user input, and then we'll print out using cout. Your score for this subject is blah blah blah. So that's the total marks for that particular student. So this is the output example. Okay, and I guess we can also try this thing. Yes, we can try this thing. Structure. So let me copy this. Let me open a recent file. To this one, and then PRTG, maybe some exercises. Then I want to create a new file, source file. Then let's paste what we have just copied. And get back to that one, the next page. Over here. See that. Paste. And of course, we need to include all this other stuff. Copy that. Yeah, so this one goes without saying. And we are going to need this stuff. And I'm gonna need another one, so I'm gonna also copy this thing for color, make my color white background. So I usually put over there in the main. And let's try to run this thing. Compile and run. So I'm gonna say structure 1. So it doesn't like this thing. So missing terminator. So I guess this one. So use that one, and also here. All right, and this one, make it closer, like that. Yeah, let's do this again. So this one must return integer. Okay, so let's change this to integer. And maybe put return 0 here. That, see if it likes it now. Hello? Hello? Okay. So let's run it here. So let's try to, oh, yeah, must declare this integer, say. Integer. So enter name. So for example, I'm going to put John Doe. Enter score for test 1. Okay, I need to fix that. So maybe put 65. Enter score for test 2. Okay, so put 75. Test 3, 89. 71, say 4. 725. So it doesn't say per what, per 5 or 10. So let's say this is 3. 74, say 5. 5 is 2. This one is say 9. 7. Final exam, say 84, 85. Project is 72. So score for this subject is 421. Okay, so that will be So a couple of things needs to be fixed in the thing. So maybe uh, the first one. So I guess this one test, you know, cut this thing, cut the thing, test, and paste it. Where here I'm gonna use this one, and then put it in between there, like that. So that'll be much better. Then we can try to run this again. But maybe we need to also look at the sample output, which is this one. So Simon is, I guess, over 5, and quizzes is also over 5. So I'm not sure. Maybe should put so test is also over 10. So this 10. So this one should be 30. So 5 is 25. Or this is 3. 15. 15. So this is over 15. 15. This is 45. So this is 15. Make 60. 60. And then we have 2 pieces. Maybe 10. 60, 70. 70. 70. This is over 15. So this is 45. This is over 3. 3 times 5 is 15. So that makes it 60. 45 and 15. So this is over 25 and 15. So 25 and 15 is 40. So that's already 110. 110. 25 and 15. 40. 40. So something's not right here. Anywho, so I guess I'm gonna stop here for now and then try to continue after this. So I guess this thing works, but we need to have some fix here. Like with this is needing integer, and over here also need integer declaration, and yeah, what else? I guess over here also need to fix here. All right, something like that. So maybe this one is should be integer as well. All right, let's continue in a bit. So I'm going to stop here and continue later. Welcome back to computer programming. So we will continue on the topic of structured data. Let me share my screen. All right. I've made some modification to the program here where we have some maybe Simon instead of S like that. How's that? ASMNT. So let's copy that. Copy that. Here as well. Big A. Simon. Or maybe Simon is tugasan. So can Simon. SMNT. Copy that. Assignment. Not the best word choice. So let's make that change for the better. Total assignment. Total assignment. This one, just make it tidy a little bit. And what else? Well, that is fixed. Yes, I think it's all good. Let's see if we can run this thing. Enter the name. So let's put what name should I give? Huh? John. How about Donald Trump? Donald Duck. Donald Duck. Douglas. Okay. Test score number 1. Give it an 8. This is 7. Next one is maybe 9. Simon, so this is maybe 2.4, 2.7, 2.5, 3, and another 3. Quizzes 2.2, 2.4, and then for final exam maybe 26, and this one maybe 15. So that gives us a total of 83.2. Okay, so not that bad. So that is that situation, and let's get back to this one, continue on this one. So you can give any input that you want. There's no wrong or right, it's just an example. So the next one, as a programmer, you will encounter many situations where you need to use array. And I remember when I was a student, a doctoral student, in my work, I had to use array, but the medium for programming that I used was MATLAB instead of C++. And then by putting the data in an array, we quickly and easily work with the data. Array of structure might look at as in this picture. And this is another example where we create data type called pelajar, where in this data type we have ID, we can have name, project mark, test mark, final mark, as well as the grade. So, and then we can create a record pelajar as a variable, and it has a size of 3. So initialization, we can also create like this, where we key in the data already. So inside it, still the name of the variable is record pelajar. But here we already have the ID 1342, and then the name in Zulaiha Ismail. You have to use the double quotation marks. And then 10.2 will be project mark, 10 will be the test mark, 20 final mark, and then the grade is F. So single character, you can use single quotation marks. And then the second input is Aina Ahmad with all the other data. And the third one will be Maria Musa. All right, so meaning record pelajar has 3 input there, 3 data related to 3 students. To print the elements in record pelajar, so here we have a for loop from 0 to 2, so 0, 1, 2, so 3 items. So and then we just print it out, see out record pelajar by first by the ID, and then the name, and then the project mark, test mark, final mark, and also the grade. So I guess this goes without saying. So you see, record pelajar will have the ID or the index before the dot. So here, meaning we have different eyes referring to different individuals, and so all included into the folder called record pelajar. So this is another name. I guess we can also test this information. You can test this code to see whether it's going to give the. So we can just copy this and try to run it. Make some changes here and there, and then see whether we can get the right input. Okay, so I think I'm not gonna do that. So, but I encourage you to just copy this thing and make some changes if required, in order to make this code executable. And then the next slide, structure as function parameters. Okay, so this is cool. I guess I used this some time ago when we do the calculation for kinematics, linkage kinematics. So it it is possible to pass members of structure to function. For example, we compute GPA. So this compute GPA is a function. So the input inside the parenthesis is stu.gpa, I guess student, and then the information is the GPA. Or we can just pass the entire structure. So the structure is stu, which is for student, I would say. And then the function is called show data. So can use reference parameter if function needs to modify contents. All right. So this is a code snippet, a structure as function parameter. So here we define a constant, which is an integer of size 50. So that is the array size. Then we create a data type called inventory. So creating a data type is using structure. And within inventory item, we have part number, we have a description, which is in its character. And then, so we use the description size 50, and then integer on hand, unit in hand. So that's the number of units available, as well as the price, unit price, and that's a double float. So and then we are just going to show item. So we just going to print it out. So that's why we use void here. So instead of so here we just going to show item. So show item, I would say this is the function, and then inventory item is referring to the structure type and or data type, and P is the function or the variable. So inside this function, we can have this thing fix show point. So not sure what to include using this because sometimes it doesn't work if we do not include certain like IO manip or IO stream. Then cout is printing the part number. So P part number, ENDL, then the description, as well as the unit on hand, and also the price in dollars. Yeah. So using reference parameter will speed up program, but function may change data in structure. Reference parameter and using constant CONST. Reference parameter allows read-only access to reference parameter, does not waste space. Okay, these are some points to ponder. Revise show item function. So this is something we can try. Constant inventory or item inventory, and we have a N symbol before the P. And then, yeah, we can try that if you want. Function can return a structure, so that's another way. So for use with the return statement, so in the function, at the end of it, before you close with the curly bracket, we have the return, so you can return with the function. I mean, with this thing, with this. Oh. We can return, instead of return 0, we can return the whole structure. Can return the whole structure. So in the structure, we can have the stems2 temporary student, I would say, and then we can get those information as the output from this function. So this is one example. Uses a function to return a structure. So here we have include IOStream, include IOManip, include CMath for the power function, and then using namespace standard std. And then we declare pi as 3.14159 as a constant. And then what else? We declare the structure. We declare the structure, and in circle we have radius, we have the diameter, and also the area. So function prototype, circle, get info, and then in the main function, we have circle C. Circle C, and then here we get data C, get info, and get info. Calculate the circle's area. C area is pi times C radius to the power of 2. Display the circle data. The radius and area of the circles are C out fixed, set precision 2. And then C out radius is C radius, and area is C area that we just calculated here, and then we return 0. Okay, so this is the function called getInfo. Okay, so temp circle, temporary structure variable, temp circle. Here we enter the diameter of a circle. Okay, and then cin, we take the input from the user. Then circle radius is basically the diameter divided by 2. And then we return temp circle. So from get info, we get temp circle. Okay. From here, get info, we get temp circle. C. So this prototype, meaning we have a function called getInfo. It is of the type of function circle, and here we say circle C. And C we say getInfo. So this is a calling function call, and then this is the function. So I guess that's about it. So that's the end of it. Maybe we'll do some exercise later on from maybe from the textbook. And with that, I guess I can end this lecture. So I would suggest you go through this slide and try to understand that, and maybe we'll talk about it in the next video. And as well as there will be a lab test or lab exercise that we'll do this final week of the semester. With that, Assalamualaikum, have a good one.